The next problem that we're going to look at is the permutations problem. Now, permutations is a similar problem to the power set problem, except it's a little bit different. Instead of trying to find all of the different subsets, we just want to find all different combinations or permutations of the given list. So for instance, all permutations of the list 1, 2, 3 would be the list 1, 2, 3, that's a permutation, the list 2, 1, 3, where we put the 2 in the front. Additionally, the list 3, 2, 1, 2, 3, 1, as well as the list 1, 3, 2, the list 3, 2, 1, and the list 3, 1, 2. So essentially, we want to come up with all different combinations of this list. Now, similarly to the power set problem, we want to think about this problem recursively. We want to be able to say, okay, let me see how I can get the permutations of a smaller list and then use that to build up the permutations of the larger list. So the smaller list naturally is going to be the same. Let's try to find what the permutations of the list 2, 3 is. So the permutations of this is going to be the list 2, 3, as well as the list 3, 2. So these are all possible permutations of the list 2, 3. Now we need a way of going from here to here. We need to find a way to insert the 1 such that we can get this bigger list. Now the key observation to make is that notice how if I did this, within all of these different permutations, the 2 and the 3 is going to be ordered in a certain way. So for instance, for these 3 permutations, notice how it's the list containing 2, 3 here. There's a 2 and a 3, and then here's a 2 and a 3. However, the 1 is inserted in the beginning, the middle, and the end. Similarly, if I move this around, this is our list 3, 2, so I have the list 3, 2, but I have the 1 in the beginning. Here I have 3, 2 with a 1 in the middle, and here I have 3, 2 with a 1 in the end. So essentially, the algorithm that we're going to approach this with is that I get the permutations of everything but the first element. Then the permutations of the entire list is going to be the smaller permutations, but putting the first element at every possible index within every permutation. So let's actually see this. So def permutations of A. So we're not going to worry about the base case. Now let me move these up so that we have more space. So what we're going to do is say, okay, all perms is equal to the empty list. So we're going to loop through the permutations of the smaller list. So for sub permutation in permutations of A, excluding the first element. Now what I want to do is put the first element at every single index in the sub permutation. So I'm going to say for I in range, the length of the sub permutation plus 1, because here the length is 2, however I need to put a 1 here, a 1 in the middle, and a 1 at the end. So I need to put it at 3 different locations if it's size 2. If it was size 3, I would have to put it at 4 different locations. So basically the length of the sub permutation plus 1 is where we want to put how many times we want to put the first element. Then I'm going to say add in all perms, and essentially I need to create a new permutation. Now I need everything in sub permutation up to where I is. Then I want to add in the first element, and then I want everything in sub permutations after where I is. And actually these should not be in lists. So essentially, let's say that I was equal to 1, and I was putting it into the 2, 3. So I'm going to get everything up to 1, which is going to be the 2. Then I'm going to put the 1 in the middle, so there would be a 1 here. And then I get everything after the 1, which is the 3. So now it would be 2, 1, 3. So this would effectively, as I goes from 0 up till the length plus 1, it'll effectively get me everything inside every possible permutation by putting in the first element in every location in every sub permutation. So I basically just need to add this in to my all perms. So add that in, and then I just return all the permutations. Now once again, the base case is when I run out of elements because I keep chopping off the first element. So if the length of A is equal to 0, then all the permutations of the empty list is simply the empty list. So if I try this, let's say print permutations of the list 1, 2, 3, I get a list containing 1, 2, 3, 2, 1, 3, so on and so forth. So clearly this is doing what we want. And essentially, this is another great example of that recursive mindset, where you have to think about how do I define this problem by first solving a smaller problem and using that solution to get the answer to the bigger problem.